All right, our lesson for today is 3-7, dividing fractions and mixed numbers. Please add this information to your notebook. Our goal for this lesson is to divide fractions and mixed numbers. Some of the vocabulary words that we're going to learn this lesson are reciprocal and multiplicative inverse. When you get to class on Monday, we'll fill out our vocabulary log. The words reciprocal and multiplicative inverse mean very much the same thing. When you multiply a number like 3 over 1 by its reciprocal, you're multiplying it by the opposite, or 1/3. So basically you're flipping the fraction, and we're going to use this rule to multiply by reciprocals when we divide by fractions. Example 1 is just dividing by fractions, and I want you to write this note in your notebook as well. Keep it, change it, flip it. Every time you divide by fractions, you're going to keep the first fraction, change it, change the division to multiplication, and flip the second number. So let's do that as we work through example 2a, 2/3 divided by 1/2. So we're going to keep the first fraction, 2/3, flip division to multiplication, and flip the second fraction to its reciprocal. So the reciprocal of 1/5 is 5 over 1. From here, we're just multiplying. 2 times 5 is 10. 3 times 1 is 3. 3 goes into 10 3 whole times, and 1/3 left over. Example B is 3/5 divided by 6, or 6 over 1 since it's a whole number. So keep it, keep the first fraction, 3/5, change division to multiplication, and flip the second fraction to its reciprocal. The reciprocal of 6 over 1 is 1/6. And we multiply. 3 times 1 is 3. 5 times 6 is 30. Can we reduce? Yes, we can reduce by 3. 3 goes into itself 1 time, and 3 goes into 30 10 times. Example 2 is dividing mixed numbers. I want you to write this note again. Keep it, change it, flip it. We're going to use that when we divide mixed numbers. But before we can even start dividing or multiplying, we have to change both of the mixed numbers into improper fractions. So we're going to multiply the denominator, the bottom number, by the whole number and add the numerator. So 4 times 3 is 12, plus 1 is 13 over 3. We're going to change division to multiplication. And then let's see, 2 times 4 is 2, plus 1 is 5 over 2. That's our original fraction, but we need to flip the second fraction to its reciprocal. So we're going to use 2/5. From there, I can multiply. 13 times 2 is 26 over 15. Because my fraction is an improper fraction, I need to change it to a mixed number. So 15 goes into 26 one whole time with 11/15 left over. That's my answer. Okay, so example B, we're going to keep the first fraction. It's already in a fraction. It's not a mixed number. So we'll keep the first fraction, 5/6. Change division to multiplication. And I need to figure out 7 times 7 is 49, plus 1 is 50 over 7. But I need to flip my second fraction, so we're going to multiply by 7 over 50. Now I can go ahead and multiply, or I can cross cancel to make my multiplication a little bit easier. 5 goes into itself 1 time, 5 goes into 50 10 times. Now my multiplication should be easier. 1 times 7 is 7, and 6 times 10 is 60. Can we reduce? Nope. This is our final answer. All right, we have one more example of dividing with mixed numbers. So the first fraction is a mixed number, and we need to change it to an improper fraction. So 4 times 5 is 20, plus 4 is 24 over 5. I'm going to change division to multiplication. And since my second number is not a mixed number, I'm just going to multiply by the reciprocal, or 7/6. Okay, I'm going to cross cancel because it makes multiplying so much easier. 6 goes into itself 1 whole time, and 6 goes into 24 4 times. Now I can just multiply. 4 times 7 is 28, and 5 times 1 is 5. Now my answer is in an improper fraction, so I need to change it back to a mixed number. So we're going to go 5 goes into 28, 5 whole times. 5 times 5 is 25. That gives us 3/5 left over. Example 3 is a social studies application. I'm not asking you to write down the problem in your book, but follow along as I read out loud. Use the bar graph to determine how many times longer a $100 bill is expected to stay in circulation than a $1 bill. The lifespan of a $1 bill is 1.5 years. If you look at your graph, the $1 bill right here is 1.5 years. And the lifespan of a $100 bill way up here is 9 years. So think, how many 1.5s are there in 9? Our problem will read 9 divided by 1 and 1/2. So using keep it, change it, flip it, we'll rewrite 9 over 1, we're going to keep the first fraction, change to multiplication, and I need to figure out how to put my mixed number into an improper fraction. So we're going to multiply 2 times 1 is 2, plus 1 is 3, and then 3 over 2. But I'm multiplying by the reciprocal, so I'm going to flip the fraction upside down and multiply by 2/3. I can cross cancel here as well, which again makes my multiplication much easier. 3 goes into itself 1 whole time, and 3 goes into 9 3 times. Now let's multiply. 3 times 2 is 6 over 1, or 6. So that means that the $100 bill is expected to stay in circulation 6 times longer than a $1 bill. Please add the explain to your notebook. Is 1/2 divided by 2/3 the same as 2 divided by 2/3? And I want you to explain your reasoning. Be prepared to share your reasoning with the rest of the class on Monday afternoon. Your notes for Lesson 3-7 should include Example 1, A and B, Example 2, A, B, C, Example 3, and the explain. If you would like some extra credit, on page 129 of your book, you can work on numbers 46 through 48. They are critical thinking problems. I hope you're having an awesome weekend, and I'll see you Monday.